Hello Internet. Today we're going to be looking at Universal Windows Platform, and specifically we're going to be building a task list in the Universal Windows Platform. So we did this sort of exercise with Blazor, which is a C# in your browser WebAssembly project. It allows you to compile C# into WebAssembly, which allows you to run C# in your browser. I kind of liked how that whole thing worked. It kind of taught us a lot about data binding and things like that. So I think it'd be kind of interesting to run through it in the Universal Windows Platform, because you can take what you learn here and kind of apply it to, say, WPF if you're working with like older, I won't even call it legacy, but just older Windows projects, or anything else that's kind of in the same vein. It should feel very similar. So I think hopefully it's helpful. And if you're new to the Universal Windows Platform, hopefully this is a good way to get you started with at least figuring out how to update your UI and manage events and things like that. So that's where we're starting. Hopefully we'll get it all done in one video. So here we go. I've just got a basic thing in Visual Studio. We have our project, blank app, and that should be it. We're good to go. We'll just use whatever the defaults are. This doesn't really matter for us. Those two features are going to affect what features are actually available in your app. But because we're just doing this demo mostly for data binding and stuff, those aren't really going to come into play. So it doesn't really matter here. Shouldn't take this long, but I guess it is. So we're just going to wait for Visual Studio to decide to respond. And then once it does, we'll need to create a view model. The view model is going to store what our view displays. So it's sort of the contract, if you will, between our data or what's actually happening in our app, the backend logic, and the front end. So it is sort of the contract that says, here is what I'm going to pass back and forth. So that's our view model. Our model is going to be, our view is going to be what you see. And then our model is going to be the backend. It's going to be sort of the data behind the scenes. I like to split things up between the model and the view model, where the model is sort of the data you're working on behind the scenes, and that can be more or less complex than what you're actually displaying. And then you'll compute some values and set that into a view model, and that actually is what gets sent to the view to be displayed. So it's sort of a transport layer. So we need to create that, a view, and then we should be good. We actually get a view just off the bat, and it looks very basic. There's two things here. There's a XAML and a CS thing. Looks like we can drill down deeper, but that's just the class, so never mind. So the first part is your XAML, which is your XML definition for your class. So this right here, this class, is going to match exactly with the class here. So you can see we're in our namespace is UWP task list, and our class is called main page. That aligns exactly with this. It's the class path, or the path to the class. You don't really need to worry about this stuff. These are some of the namespaces that you're kind of including. And then we just have a basic empty grid with a basic background theme. So this is going to actually be themed to what your OS is designed to do. These theme resources update when you change the theme. There's other types. There's static resources, which are going to be static throughout the life of an application, and something else that I can't remember, but we'll keep them as themed resources. If I could undo, apparently I typed really poorly. Theme resource. So that is, the difference is, like, if we go into settings on our computer and we change it from a dark to a light theme, or maybe we change our accent color, we want our apps to represent that without having to close them. So a theme resource is going to detect that change and actually update all of your scene. So the other part of this class, we kind of looked at this previously, is this. You'll notice this is a partial class. If you're not really super familiar with C#, partial classes are sort of partial. They're not the full definition of a class. It's a way of doing generated classes without having to manually like defines like if you look at, say, Java, because it doesn't have a way to do partial classes, you might see something like generated files below or something like that. That's just as an example off the top of my head. I'm not sure you'd ever see that, but you might see something similar to that where some point in your code becomes generated code. That's really hard to manage. It's hard to deal with that. So the way a partial class works is when you compile this project, this main page.xaml actually gets converted into C# code. So all of these things can be given like a name. So like if I give it an X name and call it, say, my grid, behind the scenes what's actually happening here is your generated code is going to create a variable called my grid, which you can actually access here because it's all within the same class. So this is how to programmatically access something. If you give it a name, you can access it. I wouldn't necessarily recommend doing that too much because that's a really easy way to kind of screw things up. Ideally, you kind of want to keep this relatively slim and put your code somewhere outside of your view. Generally, tying code and a view together kind of makes it a little bit cluttered. And especially as you like build more complicated things, it can just get hard to kind of pull components out and segment them and just keep like an object-oriented design. At least that's been my experience. You can totally build an app where everything is just in this file and it just does everything. I just wouldn't recommend it. But that's sort of how this whole thing works, is this XAML and that CS get compiled into one, and then that's actually what you see. You don't really need to worry about that because that happens behind the scenes. You don't need to see that class ever unless you break something, and then sometimes the Visual Studio compiler will show that to you. But that's totally outside of the scope of this. So what I want to do is create a grid with 2 rows. Do I want rows? Let's do columns. Good start. So we're going to do 2 columns. I'm going to divide the entire thing in half. And then on the right half is going to be all of our tasks. And on the left is going to be our UI for actually inserting new tasks. So we need 2 column definitions. The first is going to have a width of star. And the second is going to also have a width of star. And you can see it sort of draws that line there. This star is sort of a fill. And you can kind of mess with this if we want that right side to be twice as big as the other side. If I make this a star or 2 star, that's saying for the available width, I want to assign 1 of 3 to that and 2 of 3 to the other side. And that's sort of just how that works. So we have a grid. Now I can add 2 things. I want to add a stack panel, which is going to be in our grid column 0 on our left side. And I want to add another stack panel. Yeah, we'll do another stack panel on the right side. So a stack panel, there's a number of ways to lay out things in the WPF, UWP world. There's grids, which are a series of boxes, effectively. So you can draw lines. If you've ever used Excel, you kind of get the idea. It's a grid. Stack panels are either vertical or horizontal lists. The default is vertical. And so the way that's going to work is every element that's a child of a stack panel is going to be inserted underneath the next one. So if this is a vertical stack panel, if I do 2 text blocks with test here, and again, you'll see they got stacked one on top of the other. And then if I were to change the orientation of this so they were horizontal, suddenly our tests are horizontal. That is going to be ridiculously small. I'm just realizing that now. Like, there's no way you're going to be able to tell what's going on. All right, can I zoom in a bit? Kind of. Sorry, I should have planned this out a little bit more, but it's been a while. So that's probably better. You can probably see it a little bit now. So that's horizontal. We'll go back to vertical. It's the default for vertical, and they'll go vertical. Cool. So that's sort of two organizational ways. There's other things as well. Canvas, for example, will allow you to give specific coordinates to place something on, which is good for like drawing, or if you need to like overlay something on a map or things like that. But we don't need those. Those can go away. And now we have two empty stack panels. It looks really boring. That's fine, because the next thing we want to do is add a text box like so. That's just going to fill that. And I think there's a tooltip. I don't know. It has been a while since I've done this, but I think placeholder text, that's what it's called. So we want a placeholder text, and we're just going to call this our task name. And so the placeholder text is going to be sort of like the grayed out text. When you start typing, it goes away. And then we need some way to submit this. So we're going to create a button like so. And that button is super tiny. You can see that little gray thing there. That's our button. Pretty lame, I guess. Let's take this up a little bit and actually let's stick this in a grid. So grid, column definitions, and let's create again two column definitions where the width is equal to star. So this is going to create two columns that are equal distances, and I'm going to put the button on the right one. So we want our grid column to be equal to 1. Oh, it's not in the grid. That's of course not going to work. There we go. And you can see our button moved over. It's still super small, which isn't really what we want. So we're going to add some content here and just say, what do we want? One note, content is also the definition for what is actually inside of these things. So in this case, since we're using a button, I can actually just write inside of here. I don't need to define content. I can just say create task. And there we go. We've got our button. It looks kind of gross though. So let's horizontally stretch this. So horizontal alignment. If we set this to stretch, it's going to automatically fill the space in the horizontal amount. That is not how I wanted to describe that, but effectively it stretches it to fill whatever space is available. And there's also a vertical alignment that you can change for top, bottom, and center, as well as stretch. So you can kind of tweak things that way. Now that we have that, we have a way to create a task, and we just need a way to actually draw them. I'm kind of going through this all at once because I just kind of want to get the general layout done, and then we can go and write all the code that we need to actually make this work, because this won't work. So let's just start off with a really quick items control. So what this is going to do is just display a set of items. There's a whole bunch of different ways to do this, but the way items control or any of those other ones work is given a template and a set of data objects. It will, for each object in that list of data objects, it's going to draw that template each time with the data object of each set. So effectively, it's a for loop over your data set for drawing things. So in order to make this work, we need to give it an item template, like so. And we want it to be a data template. If you don't do data template, it's not going to have any idea what you're talking about. So we have a data template, and then once you get inside of this data template, it is just another thing. So we can just create like a grid if we want. And so the handy thing with doing a grid, all of these items theoretically will all be the same size. They probably won't be, but we'll get to that later. So if we do another grid column definition and set the column definition of the width equal to, say, do I actually want to do this? I don't think I do. I'm thinking on my yeah, let's do a stack panel instead. And do an orientation of horizontal. I think. And then we can do a checkbox like so, and a text block. So text block just draws static text, and a checkbox is just a checkbox. So super simple. There's no way for us to actually see what's here. We can't see this template at all. So there's a few ways to do this. You can use expression design, which is usually included with Visual Studio if you enabled the feature. And if not, then you won't see it. Another simpler way is literally to just copy and paste it outside of the item template. And then you obviously need to assign things. So like is checked down here, we can just flick that on and it becomes checked. Text block, we can set the content equal to something, so test. And that doesn't look right. So let's horizontally align this to the left. That's not going to work either because I just horizontally aligned the text block to the left, but I didn't horizontally align the entire thing. So what's ending up happening is, one, I'm pretty sure my checkbox is huge because I think this has, yeah, okay. Scratch that. Let's just drop that. So the checkbox already has an option for adding a content field. There's probably going to be something that I'm totally forgetting that allows you to do this without requiring adding in text here. So it just gets you this checkbox control. I don't know what that is though, so we're just going to use this. Why not? So there we go. We probably don't need the stack panel either. I usually like to just kind of keep something there because usually these templates tend to expand. You can also put these templates in other files and reference them that way. And then you don't need to do this. You can just kind of say the item template is equal to this other thing. But we're not doing that because this is just easier, and this way we can kind of keep everything together, and hopefully that makes it easier to understand. Or not. So we have this thing that's going to draw a whole bunch of things. Let's go and say the item's source is equal to asdiff. Oh, cool. That works now. So this didn't used to work, but you can bind to the item source with just a random string. The item source expects that list of data. In this case, this only works because a string is technically a list of characters. And so what it does is for every character, it creates an item in your list. When you don't have data binding like we don't, this actually makes it really easy to kind of figure all this stuff out. So there we go. We have this super easy list. Let's actually, just because I want to, let's stick in, that's not right. Here we go. Let's stick in a little spacer between the two. So instead of this and then this other thing over on the other side, let's stick like a 12 unit spacer between our task entry stuff and everything else. And so the way this is going to work is we just need to shift this over to a second column. And now these two controls aren't just butting up against one another. Kind of makes things a little cleaner. There's a whole bunch of ways you could do that, but that's one of the easier ways. So here's our UI. This should all kind of work. We can enter text here. We can click this button. And we've got this thing with things we can check and uncheck and text thing. None of it actually does what we want, though. We need a whole bunch of view models. So I'm going to create a folder, I guess. We'll call this view models. And so depending on what you're doing, you can either separate these or put them all together. We're going to put them all together because it's just, I don't know. It's what we're doing, I guess. And so let's create just a basic class and call them our main view models. Main view models mostly because they're on the main page. You can call them whatever you want. It doesn't really matter. But we need three things. probably need more than 3 things. But first thing, we need a static string or a public string that's going to be the task name. This will be our new task name, like so. This isn't going to work, but data bindings are done to properties. So if you've never defined a C# property, this is sort of how you do it. It's like a getter and setter in, say, Java or any other language, except there's a special syntax for this, and you can kind of treat it like a field, but you don't necessarily need to provide both a getter and a setter. So if we just wanted to be able to get this, I can just take that off. But that's that. This is the default property, which actually isn't really necessarily going to work for what we want, because it's not going to update. And I'll get to that in a bit. But the next thing we're going to need is an observable collection. Actually, let's not do that. Let's just do a list, because we'll get to that, of task view models. And so the task view models, we haven't defined those yet. That's just going to be a list of the tasks, which is going to be, is it checked and what's its name? And then we'll just do get and set. Ooh. That was not what I wanted. Going too fast. Tasks, get and set. Cool. And now we need our task view model. I don't know what hotkey that was, but it wasn't right. All right. Let's do this. There you go. Create type. Cool. Task view model is going to have 2 things. Our public string task name and a public string for, or not string, bool for is complete. And so if you check things, they're complete. And then we have our task name. So that should be everything we need to actually represent those tasks. So I think this is good. This will sort of get us started. And so we just need to bring these things into our main page. And so the easiest way to do that is just with bindings. So let's assume that we're going to bind that main view model onto this page. Once we've done that, in order to actually assign this stuff, we can do, say, text equals a binding. Notice the curly brackets there. So we're binding onto our new task name, which is going to be based on our data context. Right here, we are going to bind onto our new task name. The data context we haven't really set yet. I can do that now, I guess. But a data context sort of defines where you are, as far as data is. So it's sort of, here is the data for what element you are. So in this case, we're going to say our main page dot data context is equal to a new main view model. And this will accept any object. You can just put anything you want in there. There we go. Oh. Let's take off the S. That'll probably work a lot better. There we go. And then import that. And now we have our data context equal to this new main view model. There's nothing in it, but it kind of works. And so now we should be able to pull those in. There's a few other things. This button, not going to work yet. And we also have this item control. So we need this item source. I already kind of mentioned that's coming from our list of things, which is going to be, it doesn't look like it has autocomplete. That's too bad. But we can figure that out by just grabbing our tasks. Going to all the wrong places. Here we go. Our tasks. And then we need 2 things here. There's an is checked, which is going to be bound to is complete, I think we called it. And then our content, which is going to be bound to the task name. One thing I would point out, this is a content. The checkbox is content. It's not just a text thing, which could have some interesting implications. We don't necessarily need to just have a string in here. Since it's accepting content, we can put pretty much anything we want. If I wanted some really complex like image or something, you can do that, and there's nothing that's gonna stop you. So you're free to kind of go and do what you want. But this is what we need for now. So we have is checked, content, everything else. So it all should be bound and doing its thing. It's just not really, it's not really going to do what we think it's going to do. I'm going to put a breakpoint on both the new task name and the tasks. If I run this, we should hit those breakpoints. Something should happen. Don't really know what, but we should hit something because we're going to be getting the new task name because we bound to it, unless our binding isn't working. But I imagine that is. The issue we're going to run into is like if I type into this text box, here we go, we're getting it, and then we're getting our tasks. As we continue, things happen. We've got our task name now, so I need to insert that. Let's just type a test in there. Now, I no longer have this selected, but we didn't hit our breakpoint again, which should have happened if we say hit a set. And so part of the issue we're running into is we have a one-way binding that's coming from taking stuff from our view model and assigning it to the UI, but we don't have anything that says, hey, you should go probably update the UI. So let's maybe add that, because that's not going to be very, very useful for us. So how do we do that? In order to update both of the things, there's an option called mode, which is two-way. So this is actually going to say, I want to mirror changes from the UI back to the view model and from the view model to the UI. So it goes both ways. The default is one way, from the view model to the UI. What just happened? I don't know. And there's a third, which is one time, which is effectively going to take, at the time of rendering the page, it's going to take that data and never watch for changes. So by default, there's a way that we haven't really talked about on how to actually watch for changes in your properties. If you set it to one time, that's not going to be checked, which in some cases may be what you want. So we don't care about two-way binding to our tasks because it's just reading from that task list. We're never going to be updating it from our UI. That wouldn't really make any sense. We're just going to be able to check boxes and then type in a new name. So those are really the only two things we're doing. And so now, if I launch this again, we should see the set get called after I probably deselect our text box. I believe that's the behavior I expect. So we can skip over both of these, get here, type in a test, and I get confused because that didn't do what I wanted. And maybe it said it only on the get, and I would feel silly because then this example would be poor. But yep, okay. Well, I've made the change already, and I just totally didn't even demonstrate the problem, but that's all right. We'll actually see a set here, I hope. Like 90% sure. It doesn't call set as we type. You can change that, but by default, it only calls set when you deselect it. So when I hit tab there and move on to the button, we get this set with a new value of test, which is going to set this new task name to test, which is for what we're doing, that's fine, because we don't need to like auto update like a list or do a search that's happening like constantly as you type. If you need that, you kind of have to play with this a little bit more. But for basic stuff, the default is fine. So that's pretty much everything there. The only other thing that we'll really need to do is actually tie in a button. There's two ways to do this. Two good ways that I know of. The first is with a command, which is abstraction. Let's actually look at that. So let's just call this commands. And so a command implements the ICommand interface, which is a 2-function interface, I believe. So let's say create task command. I think this is what I want to do. I hadn't really intended to cover this, but sure, why not? So ICommand comes from here, system Windows input, I think. I know what it's supposed to look like. I don't know where it comes from. Yeah, this looks right. Cool. So there's 2 functions and an event, which kind of gets into the whole updating the UI thing. So the first one is can execute. This can always execute. So we're going to set this equal to true. Actually, let's not. Let's say our parameter this isn't really what we want. We're getting an object from here. Let's not use an object. Let's grab our main view model, because we're just going to pass in the entire view model, because why not? So a command can take a single parameter, and given that parameter, it can execute it. So in this case, our button has a whole bunch of things on it that we can call. So there's like a click. This is an event that is called when you click it. There's a whole bunch of these, but it also has a command. And so the command is also called when you click the button. It does a few extra things too. So like this can execute, for example. If your command can't execute, the button gets disabled, which means you can't click that button because the command can't be executed that the button is bound to, which kind of gives you some extra features with some nice abstraction as well. So we're going to save this as our main view model. View model equals our parameter as our view model. That's not how you do that. Main view model. There we go. So since we're casting it like this, there is the potential for it to be null. So we're going to test for that. So if our view model is not null, then we'll do what we want. Otherwise, we're not ready. And we'll just return false, which effectively means our entire app just broke if this ever becomes false. It says we can use, oh, cool. I think this is how you do that. One sec. Cool new C# 7, 8 features. I don't remember how to use that. One sec. Pattern matching got added in C# 7, which lets you do some interesting things. So here we have, it's suggesting using pattern matching. There we go. So the way this works is when you do something is, that's what I was getting wrong there. But if you say a parameter is of the main view model, what you're doing is effectively it's a function that returns a Boolean and says, is the parameter of type main view model or does it inherit from the type main view model? If that's true, it returns true. And if that's false, it returns false. That should be self-explanatory. The cool thing that was added with pattern matching is you can give a name at the end and it assigns the result of this into the view model. So what this is doing is saying if the parameter is of main view model, set the variable of view model equal to the casted version of parameter as a main view model, if that makes any sense. So effectively this view model here is the variable parameter cast into a main view model, which is pretty cool. It means this gets way easier. So now that we have that, we can take this and do all sorts of normal stuff. What I want to be able to do is effectively return if string.is null or empty, null or white space. So if you enter a null string, which shouldn't ever happen, or you enter just a bunch of spaces for whatever reason, you can't use this. So view model dot new task name. We'll just do that. And so what that's going to do is effectively return true if you've entered text, otherwise false. Cool. So that's our can execute. We're going to have to come back to that because I'm pretty sure I need to implement this as well. But we'll get to that. Or can execute changed. That's probably the easiest way to do this, isn't it? Just change the can execute changed, invoke that constantly. Dot invoke this an empty event args. Sure, I've never really worked too much with these can execute things, so I'm kind of guessing in the dark here on how this is going to work. But I'm pretty sure I should just be able to invoke this. If this isn't working, we'll figure it out. But that's sort of one of the grayer areas in my knowledge here, so we'll work through it if it doesn't work. But that, hopefully, will work. Let's actually stick that in a null continuation operator. So what this is doing, if you can't see, is there's a question mark and then a period. If this is null, if can execute changed is null, it doesn't execute the stuff on the right. If it isn't null, it does, which is effectively just a really short way of saying if this is not null, then do this. But we can do it all in one line. So cool, fun little C# hacks. Now that we've got all of that, I think we're good. So the other thing that we need to do is actually do the actual execution, which in this case should be fairly straightforward. We just need to take our same thing here. We're not returning anything, so this is just going to be a return, an empty return. It's just a void function. And if this does work, then what I want to do is take our view model dot tasks and add a new task view model with is complete equal to false, and the task name equal to the view model dot new task name. So effectively we're taking the new task name and assigning it to a new task. And then I want to take our view model dot new task name and set that equal to an empty string, just to reset that and just kind of make sure that everything has done what we expect it to. And because we did that, we should probably do can execute changed, because that's just what we should do. And so can execute changed, to my understanding, is actually going to tell the object, so in this case the button, that something has changed. Otherwise the button isn't going to know that this can execute has actually changed its result, and that it needs to actually redraw that part of the UI. That's my understanding. It could be wrong. Again, that's kind of a grayer area for me. So in this case, we're just going to invoke this again, because why not? If it doesn't work, it will either blow up or silently fail, which isn't really what I want, but I'll probably have to do some further reading on that. So anyway, the general idea, add the task, null out the name, and then just say can execute as changed. The reason we do this is because we set the new task equal to an empty string, which should mean this is now false, which means our UI shouldn't work anymore. So that was a really long tangent on commands, but we finally got there. So what I need to do is actually add this command into this set of things, and that way we can actually bind to it. So let's create a public create task command with a get. That's not right. Command. There we go. And this is going to be create task. Sure. Not so sure about the names. We need to actually set this. So I'm going to create a private create task command, which is just going to be create task equal to a new create task command We don't have any parameters for this, but we're just creating this. And I don't need to set it, so we can actually get rid of that. And instead of this default get, we're actually going to return a create task. I don't need to do this. What am I doing? We can use a lambda, because I guess this episode is just all about crazy C# things. So this is effectively overriding the get and completely ignoring a set, and effectively saying when you call this property, return a new create task, which should be fine. That's what we want. So cool. Everything should be working. We will be adding to our tasks. I'm going to add some spaces here so we can actually look at this, because this isn't going to do what we want. It's definitely not going to work. I'm going to stick a breakpoint there as well, because we're just putting them everywhere. Actually, I'm going to take it off this because we know those are getting hit. But the set for the tasks shouldn't ever get hit. That actually might cause a null pointer error. We'll see. And then the other one is inside our create task. So the next thing to do is bind this create task onto our button. So we have this command. Let's bind this to that create task command. There's a number of ways you could do this. I like putting them in the view model. You can actually stick them into the UI and actually reference them as resources too. That works. But I found this works for me. So yeah. So now that we have that, we should actually get to be able to call this if we ever get an update to our actual thing. So I'm going to want a breakpoint in here. And that should sort of help us figure out what's going on. I imagine this is going to get called now. Stack Overflow. Oh, we probably don't need to be invoking this constantly, do we? I imagine what we just did is call this a bunch. Yeah. I'm going to take this out. Pretty sure. Actually, there's an easier way to figure out what's going on here. There's an event handler occurs when changes occur that affect whether or not the command should execute. I don't think we need that. I'm like 95% sure. I think we just need it in execute, but I could be wrong. We're gonna try it without and see what happens, because I don't know. So there we go. No Stack Overflow. That's progress. So our parameter is null, and that's because we didn't set a parameter. So that just went to false, and now our button is grayed out. So our button, because we hit this false thing, I didn't actually show that, but that's what happened. We can't actually do this. So effectively, the button is now disabled. So we probably want a parameter there. Let's do that. In order to do that, main page, that we have this command, there's a second thing, which is the command parameter, which we want to set equal to a binding. And I'm just going to leave this empty and use the default binding. The default binding is currently the data context, which in this case is going to be the entire view model. So it should just grab the entire view model and use it here. I screw this up like 50% of the time, so that may not work. Doesn't appear to have worked. View model, oh, it did work. Parameter is equal to a main view model. We've got this. This is null because we haven't actually executed that yet, but a parameter is not. So if I step over this now, our view model becomes the main view model. It's actually set there. Cool. So that's actually working. That's progress. If I do test here and hit tab, our button's still disabled. That's not good. Why is the button still disabled? probably because we don't want to call this in an infinite loop. All right. For now, I think the best thing is to just turn all that off and just return true. It ignores some of the issues of actually doing that, and it allows you to actually manually handle that as well instead of doing it with the command. It's good and bad in my opinion. I'm not super fond of it. Like, our create task works now. I can click it and this will actually go here and do things, which I don't necessarily want. No reference because we don't actually have a task name because I didn't set anything in the string. Things like that. That was previously being disabled. One of the cool things though, we got to this thing, which is this gross generated stuff. So if you see like a g.i.cs, that's your generated code from that XAML and your CS files. It looks like this. In UWP, you have this fun stuff which is actually like attaching debuggers and stuff like that. You'll always hit here. Pretty much if you throw an unhandled exception, you're gonna hit this line of code, and then you have to look at the exception manually and kind of figure out where it was. It's not the most elegant of things. It kind of can be really frustrating, especially if the bug is already hard to find. It just is it's abstracting the debugging process. And I'm not a big fan of it, but that's just the way it is. So we can continue past here and our entire app will crash because that's just what happens. So if you edit code in here, it's not going to do what you think. Because again, generated code, it's going to go away. So probably not the best idea to edit stuff here because it's not going to do anything and you're just wasting your time. So let's fix our task name being null. Let's set a private string new task name equal to just an empty string. And our get will return the new task name, and our set will set the new task name. So new task name equals our value. There we go. Semicolon. Use an expression body. I don't want to use an expression body. We're getting there. So this is sort of, yeah, basic property stuff. Resharper is saying I can optimize that, and I can. We're just not going to, because there's a reason I wrote it that way. So now if I do this, we shouldn't get that null pointer. We should actually be able to create things, and hopefully everything works. I could be wrong, and it could all go horribly, but if I delete all of that, create task, task name is empty, our tasks is null. That's where the null pointer was coming from. What am I doing? Tangents. Going on tangents. Private list of task view models. And we'll just call them tasks. New list. There we go. Ooh, not that. And let's just copy what we did above. Tasks equals a new, that's not right, equals the value. Tasks. Cool. So that should cover our tasks, and now we can hopefully move forward. We won't get those null pointers anymore because our list is now defined. Why do I keep typing? Create. That should work. If I step over this now, we don't get an error. Yay. And now we can continue. So it'll step over everything and do all of that. And now we have an element in our list, but we don't see anything. It's probably in the list still, and I can confirm that by doing a create task. If I look at the tasks, the count is 1. We haven't added the new one, but we have this empty one that we previously added. So it's there. Our UI just didn't update. So what's happening here is there is no way for the list to tell the UI something got added. It has no way of doing that. And so that doesn't really work. And so basically you can't use lists. That's the basics of it. So this whole thing is just not working. We're getting things in our list. That's working. This is now at 2. So it is counting up when we're actually getting things. Our UI just isn't knowing that it needs to redraw stuff because we added stuff. There's a way to solve this. And unlike with Blazor, I do know how to solve it. So the way to do that is create an observable collection. And what these do is implement some fun interfaces that have a, ooh, that is not what I wanted. That have a fun little way of telling the UI something changed within me. So I had something added, I had something deleted, I had something that moved. And you can implement these all yourself. The interface is going to be iNotify collection changed and iNotify property changed. We'll get to this in a bit, I imagine. But for now, that's the important one. iNotify or collection changed is what's actually going to tell us that things have moved. You probably can just get away with using observable collection for like 80% of what you do. But if you need to implement it yourself, just implement that interface and the UI framework will figure it out. So now that we're using that, we can actually use a collection, iCollection. I think that's what we want. Can't really do that because we have a new observable collection. This will have to work. So the way this works, we have our observable collection. It exists there. And now we return that. None of the magic is happening here. What's really happening is in our command, when we do this add, we're adding into the observable collection. Once that happens, the notify changed event fires that is going to say something got added into my list. You should do something with that. And the UI hears that event and then does stuff with it. So this is sort of the way WPF and UWP are sort of structured. Everything communicates with events. It's all very event driven. All of your interactions as a user with the UI framework are all events, whether they're clicks or drags or typing or whatever. That's all events. And then all of the things that say, hey, something happened in the backend, you should change the UI. That's also events. You don't have to use events, but that's sort of the way it's sort of built. So there you go. Now we can do this, run everything again. Should look exactly the same. We just replaced our list with something that's a little bit more tuned for what we want. So if I click create task here, we had 0. And if I continue, now we have that 1 and it's actually showing up. So this is actually working. And I can actually type. Interesting things are happening though. You see it still says test, but everything is blank. Because we set it back to 0, or we set it back to an empty string, but we just changed a string. We didn't. How are you going to know that a string changed? There's no way you can know that. So that second property here, if we go back into this, that we were talking about iNotify collection changed. The one we care about in this case is iNotify property changed, which is actually going to say, hey, something changed on inside of me, or one of my properties changed. So we're going to actually need to implement that so that when our string changes in the backend, we can actually tell the front end that, hey, it changed, you should probably redraw that text box. So let's go here. Can't do that while we're running. We'll implement that. And that should have done it. Nope. It was worth a try. We're still missing it, even though I told it to implement it. Fun stuff. Sure. And I just implemented those methods using ReSharper. I'm going to delete everything that's here. There's some fun stuff there that we won't really talk about. But what's going on here is onPropertyChanged is the new event. So the two new things that were added when I did all that auto generation stuff was this public event, which is for property changed. That actually gives what gets fired. And then there's an onNotify or onPropertyChanged. That isn't part of the interface. There's nothing there for that. That was added by ReSharper. And it's sort of the standard for how these things are called. For events, it's just sort of on and then whatever the event is. So in this case, onPropertyChanged, it takes a property name, which is the name of the property that got changed. ReSharper does a lot of magic to make that do cool stuff. I've covered that a little bit in other videos, so I'm not going to go super into it. This is a little bit lower level basic stuff. So we're not going to cover like pulling the names out of the compiler, but we are going to do a little bit of that. So the way this works is we need to call property changed with our invoke of this object. So we're saying our main view model changed, and the new changed stuff has a property with a name of property name. And so the way this works is you give it a name of something that changed. The UI says, oh, I have something that uses that. I need to go and update. And so it does. That's pretty much the entirety of it. So this is our basic onPropertyChanged. If the property change is not null, which it will be null if nothing has subscribed to it. So you kind of have to test for that. You'll get a bunch of null pointers and you won't know what's going on if you don't do that. And then we just give it the name. Cool, simple stuff. We don't need to change our get here, but this set isn't going to work for us. So we need to change our set. So if the new task name is not equal to our value, so if it's different, then we want to actually do something. If it is the same, we don't really care. We can do exactly nothing because we just set it to the same thing it already was. Why update the entire UI or redraw anything if it didn't change? So in this case, we want to do a new task name equals our value, like so. And then we want to call onPropertyChanged. That's not how you do that. onPropertyChanged. And I'm going to use some more C# magic, which is the nameof operator, which if I give it, say, new task name, that is actually going to be the property. It's actually referencing the property. Instead of having to actually type out the name like a string. So by default, you would just do this. You just give it in a string. That works. It will do exactly what you expect. But you can get into some tricky situations, especially if you like have a bigger application. The issue you can run into is, let's say I want to rename new task name to created task name or something like that. If I do that, it's going to rename everything except that string, which is going to be wrong, and then my application isn't going to work anymore. Some things like Visual Studio and ReSharper will catch that now, but not everything will, especially if you're using like a basic text editor. So it's not the safest thing to do. The nice thing is if you use nameof, you're not referencing a string anymore. You're referencing the property itself. And so if that property changes, it will have to refactor that as well, which makes it really handy. So I don't know. I found that trick is really helpful, especially when you just need to reference the name of something. It's a really handy feature. I think it came in C#6. I don't know. It's been around for a few years, so it should be available to you, whatever you're working with. So new task name, that should do everything. And so what's going to happen is if we actually update our new task name, we're going to call this. The UI is going to pick that up and figure out what it needs to do. Which means when I create a new task now, we should actually see that get reset back to an empty string. So if I do test here, when I create a task, our new task should show up and this should be cleared. If it isn't cleared, then something's wrong. And it was. Cool. So everything's doing exactly what we want. And so I can add more of these, like, I don't know, make more videos, and add another task, and we just get more stuff. And everything just kind of behaves like you would expect. There's a few more things, like these checkboxes are more for show than actually any use. But you sort of get the idea. Everything we've done here, you could just kind of expand to make those do whatever you need. So I'll leave it here. I think that's probably more than enough of a deep dive into how all of this stuff works. Some of it was kind of tangential and we kind of got off track, but I think it kind of helps emphasize some of the cool stuff and some of the, I don't know, complicated stuff of how all of this stuff fits together. So if you want to see more of these like longer deep dive things into specific frameworks like UWP or something like that, let me know. Another thing, we did UWP here, the Universal Windows Platform. All of this stuff will work in WPF. There isn't anything we did here that doesn't really apply to WPF. So if you want to bring that, or you're coming from one or the other, it should work interoperably. You should be able to take one and put it in the other one. They borrow from one another. There's just a few things that are missing. The UI will look a little bit different, for example. But for the most part, it's all the same. But yeah, I'll leave it here. If you guys have suggestions or feedback, let me know. But that's it for this video. So until next time, see you, Internet.